Assalamualaikum and good morning everyone. In this video, me and my team will talk about technique of differentiation. Me, Tengku Ed Iskandar bin Tengku Ahmad Sapain, and my group members which is Muhammad Hail Zahran bin Zamri, Tasnim Bila Izzah binti Badul Hisam, and Nur Izni Izzuin binti Mazlan. So, what is differentiation? Differentiation is a fundamental concept in calculus that measures the instantaneous rate of change of a function with respect to a variable. It calculates the slope of a curve at any given point, thus representing how output changes as input changes. It is often denoted as dy/dx or f prime x. It is essential for finding maximum and minimum values and analyzing motion. In this differentiation, we have 4 common techniques, which is power rule, product rule, quotient rule, and chain rule. Why we have 4? It is because different techniques of differentiation are needed due to mathematical function vary greatly in complexity and form. Thus, using a single universal method is inefficient and time-consuming.
For a constant function where f(x) equals to c, the derivative is 0. This means that a constant value does not change, so its rate of change is 0. Next, for a power function f(x) equals to x to the power n, the derivative is f(x) equals to nx to the power n minus 1. This rule is known as the power rule, and it is one of the most important differentiation rules. Moving on to trigonometric functions, the derivative of sin x is cos x. The derivative of cos x is negative sin x. The derivative of tan x is sec squared x. The derivative of sec x is sec x tan x. Lastly, for the exponential function f(x) equals to ex, its derivative is still ex. This slide explains the product rule, which is used when a function is written as the multiplication of two functions. The formula for the product rule is f prime x equals to u prime x v times uv prime x. Next, for question 1, we are asked to find the derivative of the function using the product rule. The given function is f(x) equals to 2x cos x minus 2 sin x. For the solution, first we let u equals to 2x and v equals to cos x. Then we differentiate both. So for u prime, we will get 2, and v prime, we will get negative sin x. Now we substitute into the product rule formula. So dy dx equals to 2 cos x plus 2x in bracket negative sin x. Next, we include the derivative of the second term, which is negative 2 sin x equals to negative 2 cos x. Putting everything together, dy dx equals to 2 cos x negative 2x sin x minus 2 cos x. The 2 cos x terms cancel out, leaving dy dx equals to negative 2x sin x.
Now, let's look at quotient rule. We use quotient rule when we encounter one function divided by another. So first, we need to identify the numerator and denominator functions. Then, we need to differentiate the numerator and denominator functions and apply it to the formula. Let's look at question given. Find f prime x of the following functions using quotient rule. First, we know that the top number in a fraction is numerator and the bottom number in a fraction is denominator. Then, we represent u as numerator, which is 2x squared minus 1, and v as denominator, which is x squared plus 2. Second, we find u prime and v prime using power rule, which we need to identify the exponent and then multiply the function by the exponent and reduce the exponent by 1. And we get the differentiate of u and v, which is u prime equal to 4x and v prime equal to 2x. Now, we need to substitute the function to the formula, which is vu prime minus uv prime divided by v squared. Then, we need to expand the top fraction. Last but not least, we simplify it and we should have the final answer like the answer given.
Now then, I'll be explaining about chain rule. The formulation is what we are going to use for chain rule. Now then, chain rule will be used anytime we see a function inside another function, or in simpler words, a composite function. To use a chain rule, we need to first identify the outer and the inner function. Then, we need to differentiate the outer function with respect to the inner function. Afterward, we will multiply the differentiated outer function with the derivative of the inner function. Now then, let's try an example. The questions required us to differentiate the following function by using chain rule. The function given is y equal to x squared minus 3x cubed to the power of 14. Now then, to solve this question, we first need to let gx equal to x squared minus 3x cubed and fx equal to x to the power of 14. We are then need to differentiate both of them, which lead us to get g prime x equal to 2x minus 9x squared and f prime x equal to 14x to the power of 13. As the formula required us to multiply f prime gx with g prime x, we need to find f prime gx. To do that, we need to insert the function gx into the function f prime x, which give us 14 times x squared minus 3x cubed. Finally, all we have to do is multiply them both. As shown here, there's nothing much that we can do afterwards, so this will be our final answer. To conclude everything that we have said so far, differentiation is basically how we find the rate at which something changes. We don't always use the long official formula, but instead, we learn shortcuts called rules, such as the power rule for simple function with exponent, the product rule for multiplication, the quotient rule for division, and the chain rule for functions inside other functions.